The quiz on molecule shapes considered really just a few molecules and then asked you quite a few questions about them. So let's just draw out the molecules that they asked you and then consider all of the different things that you needed to know. So carbon tetrafluoride would have been carbon. If I draw a Lewis dot diagram for that, fluorine has got 17 electrons. 7 electrons, sorry, 7 valence electrons. Draw that out. And what you can see quite clearly is that there are 4 bonded pairs. So we're going to go like that, like that, like that, and like that, and like that. So these are shared pairs. There are 4 of them, and there are no lone pairs at all around that carbon. So if I consider the steric number of the carbon is 4. There are 4 bonds or 4 lone pairs altogether, but the number of lone pairs is 0. If I take a look at hydrogen sulfide, sulfur looks a lot like water. If you consider that it's in the same group, it has 6 valence electrons. Hydrogen brings 1 electron to the bonding. And we then have sulfur with a steric number of 4, but it has 2 lone pairs and 2 bonds adding up to the steric number of 4. Hydrogen phosphide, phosphorus is in group 5, just like nitrogen. So when it bonds with hydrogen, it's going to look a heck of a lot like ammonia in terms of shape. And therefore, you have got a steric number of 4, 1 lone pair, 3 bonds, which add up to 4. Carbon disulfide, if you take a look at it, looks quite a lot like carbon dioxide because sulfur is in the same group. So I'm just going to draw a Cooper notation for that, and your carbon disulfide lands up looking like that. Its steric number is 2 because it only bonds to 2 things with a double bond, but it bonds to 2. There are no lone pairs at all in that. What are the shapes of these molecules? Well, the shape of the carbon tetrafluoride is the same as methane and carbon tetrachloride, which is going to be tetrahedral. It has got polar bonds, but it is a non-polar symmetrical molecule. If I take a look at hydrogen sulfide, it looks just like water. So again, it's a polar bond, it's a dipole that is created, and it is a polar molecule, and its shape is bent. If I take a look at the hydrogen phosphide, it's going to look like ammonia. It is going to be a polar molecule as well. Well, it's not actually, because what happens is that these bonds are actually, if you looked at the electronegativity difference, it's 2.1 and 2.19 or something. So phosphorus and hydrogen have almost the same electronegativity, and therefore these bonds are nonpolar bonds. But because of this lone pair over here, that will cause a slightly negative and a slightly positive to arise. So overall, it is a polar molecule, but it has non-polar bonds, which is almost different from this, where you've got the polar bonds and symmetry. Here you've got non-polar bonds, but you have asymmetry because of that lone pair over there. So its shape is going to be trigonal pyramidal, just like ammonia. And the carbon disulfide is going to be linear, just like carbon dioxide. If I look at nitrogen, I land up with that triple bond. It is also linear, and because there's no electronegativity difference, it is a non-polar covalent molecule. Hydrogen fluoride, hydrogen and fluorine, single bond shared. You've got no shape, it's just 2 atoms, it's linear again, but this time you have got polar covalent, and that creates something called a dipole. And this side slightly positive, and this side is slightly negative with the electronegativity differences. And we've already worked on the carbon disulfide.